Now let us solve the problem. For simplicity, let me put the system of equation in front of our eyes so that we can keep track of what is going on. So as usual, if you want to answer these sorts of questions, you know that you need to set up the augmented matrix of this system. So let me do the same. So this is the augmented matrix of this system. So you see that these numbers 3, -1, -1, and 1 are actually forming the first row, and this -2 that you see here is written here. The same thing for the other rows. For example, here there is no x, so the x coefficient is 0, and then I have 2a and 1 and b as you see, and the same thing for the last one. So I need to change this augmented matrix to a row echelon form. Okay, so what I do, I start with this column because this is a non-zero column. What I need to do, I want to give the role of my pivot to this number 3, and then using that I want to make these two entries 0. This is already 0, so what I have to do, I have to multiply the entries of this first row by -1 and add it to the third row. Yes, so I multiply the first row by -1 and add it to the third row and replace the third row by this new entries. Okay, if you do that, this is the matrix that you will get. For example, if I multiply this by -1 and add it here, this becomes 0. If I multiply this by -1, which becomes 1, and add it here, it becomes 4. If I multiply it by -1, it becomes +1, added here, a plus 1, and etc. Okay, and as you see, I haven't even touched the first and the second rows. Okay, so far the first column is good, but I need to get rid of these 2 because now this 2 is playing the role of the leading non-zero term or the pivot, and I want to use that to get rid of this 2. So what I'm supposed to do, I have to multiply this second row by -2 and add it to the third row. So I multiply everything here by -2 and add it to the corresponding entry from the third row. If you do that, you will get this matrix. So for example, if I multiply this by -2 and add it here, of course you know that if I multiply this by -2 and add it here, nothing will change. If I multiply this by -2 and add it here, I will get 0. If I multiply this by -2, it becomes -2a. When I add it here, -2a and a becomes -a, and then I have +1. So instead of writing -a plus 1, I have written 1 minus a. And the same thing here. For example, if I multiply this by -2 and add it here, it becomes 3 plus b minus 2b, which becomes 3 minus b. Okay, so now I hope that you agree with me. This is in a row echelon form. This matrix that you see, the whole augmented matrix in a row echelon form, and we don't need these two matrices anymore. So let me just get rid of them, not distract our attention. Okay, and then we put this matrix in focus. Okay, so if I ask you how many pivots you see in this matrix, you definitely tell me 3 is a pivot or a leading term, and a leading non-zero term, and 2 is also a pivot. But you cannot say for sure that 1 minus a is also a pivot, because if a is equal to 1, then this entry becomes 0, and this doesn't have any pivots except the last one. Okay, so here we are certain about the number of pivots is either 2 or 3 if a is not equal to 1. Okay, so 3 and 2 are pivots for sure, but 1 minus a is not certainly pivot unless a is not equal to 1. Okay, so what we can say is that the number of pivots, I am using this notation to show this is the number of pivots. So the number of pivots is 2 or 3, but you know that the number of variables is 4. It's clear, x, y, z, and w, there are 4 of them. Okay. And then we know that the system has a unique solution if and only if the number of pivots is exactly equal to the number of variables, which of course cannot happen for this system because the number of variables is fixed 4. The number of pivots is either 2 and 3. In any case, it will not be equal to 4. So what is the conclusion? The conclusion is that if you want to make the system to be a system with a unique solution, it is not possible. Okay, so for no values of a and b, we can have this. So the answer to the first part of the question is actually no values. Okay, so let us now go to the next step. We know that a system has no solutions, in this case we call it inconsistent, if and only if in a row echelon form of the augmented matrix we can detect a row of this form. What that row is? A row of this form. You have a bunch of zeros before this vertical line, and then you have C, which is not equal to 0. If this happens, it means my system is inconsistent and I do not have any solutions. Okay, now let us go back to this matrix. So there is no way for me, if I want to reach to this one. For example, the first row cannot be like this, because evidently you see that none of them is 0 up to here. The second row also cannot be a row of this form, because even though you can fine-tune A, but still 2 and 1 are non-zero. So the only possibility for me to make such a row is to think about the last row. Okay, so if I choose A so that this expression is also equal to 0, then I will have 0, 0, 0, 0. And if I choose B in a way that it is not equal to 0, then I reach to the goal of inconsistency. Okay, so that is actually the idea. So 1 minus A should be 0, and 3 minus B is not equal, shouldn't be 0. So of course this means what? This means A is equal to 1 and B is not equal to 3. So that is actually the solution to the second part of the equation. Okay, now let us go to the next part, which is the last part. So what I want to do now, I want to fine-tune A and B, if possible, to have infinitely many solutions for my system. Okay, let me review. We know that every system has either a unique solution, or no solutions at all, or infinitely many solutions. There is no other cases. Okay, but we just learned from part A that unique solution actually cannot happen. It is not possible. So let me just remove it from the display. Okay, we are left with two other possibilities: no solutions and infinitely many solutions. In part B, we answered when no solutions occurs. And that we learned it occurs if A is equal to 1 and B is not equal to 3. So if I ask you, do something that this happens, infinitely many solutions happens, it means do something that no solutions does not happen. Okay, but no solutions happens under this condition. So if you want to do something that no solutions does not happen, consequently infinitely many solutions happen, you have to negate this statement. Yes, so we have to negate that statement. This symbol means negation of this. This is not the case that this happens. This is how it reads. Okay, this is not the case. What does it mean? It means that this is not the case that A is equal to 1 and B is not equal to 3. It means A is not equal to 1 or B is equal to 3. If you just think a little bit, this is the translation of this negated sentence. Yes? So that is also that is the answer to the third part. So the third part tells you that A is not equal to 1 or B is not equal to 3. But if you think, you can write it in a little bit different, because when I check the solution by the examiner has written this in a slightly different way. What does it mean? A is not equal to 1, so you want to have at least one of these conditions. A is not equal to 1 or B is equal to 3. What does it mean? If you think deeper, it means that If A is not equal to 1, I really don't care about the value of B, because here I need either this happen or that condition happens. So this means that A is not equal to 1 and B is any real number. So as far as A is not equal to 1, this OR condition is append, is fulfilled. So I don't really care what B is. But there is another scenario. What happens if A is equal to 1? So this means this is not happening. Then I have to make this happens, okay? So or A is equal to 1 and B is equal to 3. So actually this is the solution to this problem. I hope that this video was useful for you. Until the next video, be safe and goodbye.